Good morning to all. I welcome all our students on the grateful occasion on the online webinar class. So I thank us Chairman Sir, Secretary Sir, and Principal Madam and Dean Sir on this grateful occasion. Kindly make use of the online class very well. So here the third year, I'm going to take class for the 5th semester. The topic is optics, 5th paper. So first of all, we have to know about the optics. Okay, so we can see that the optics is subdivided into 5 units: geometrical optics, interference, diffraction, and the 4th unit is polarization, and the 5th and final unit is fiber optics. So these are the 5 units we are going to cover. So we have to know first of all what is optics. The primary thing we have to know. Okay, so what is the relation between optics and light? Okay, so first of all, we learn the reality by means of our senses. What are the senses? Eyes, ears, nose, tongue, skin. Okay, so from this we are using our sight for learning object. Okay, by observing. Okay, by light we observe the object. Okay, so these are the primary thing we are going to see about the how the light acts. Okay, and then after, what is light? Okay, what is made up of? Okay, well, light is made up of what? How is it generated? How it is being generated? How fast it travels? How does it propagate across the empty space? How it passes through the empty space? So how this penetrate the object? Okay, how are the interaction? What are the interaction it happens towards the object or material? So these are the questions which arise on the mind. Okay, so the optics is a branch of physics which deals with this phenomena and laws. Okay, according to the generation and propagation of light, interaction with matter. Okay, first of all, if we see the brief history of development of geometrical optics, it was being observed by the Greek scientists. Okay, the Greek philosophers and scientists, they are having the say various laws. Okay, so from 300 BC before it has been observed. Okay, after development of geometrical optics, so in 1960s, 1675, Isaac Newton also proposed corpuscle theory. Okay, so he was also having a theory called corpuscles. Okay, and then after, various other scientists discuss about this, the development of wave optics. What are the development happened in the wave optics? Huygens in 1678, he is a contemporary of Newton. Okay, so he is the reflection of the Newton. He reflect the thing about the Newton. Okay, so so various other scientists also have a base on Newton. Okay, so and then after, nature of light. What is the nature of Faraday? Faraday has the magnetic field interaction between the electromagnetic force. So he has the relation how the electromagnetic force acts towards the light. Okay, so he is also having a various theories. And after when further it is being proceeded, the development of quantum optics. Okay, so after it is being observed that Fraunhofer discovered the dark line in the solar spectrum. Okay, so he produced that. He is telling that the quantum optics. Okay, so he is developing the quantum theory. Okay, so quantum optics. So mainly the theories are subdivided into four classics of theories. Okay, what are the things? First, it is corpuscle theory, wave theory, electromagnetic theory, and quantum theory. So these are the basic theories which they discuss from the earlier. Okay, so first of all, the corpus theory came after it is being upgraded to the wave theory, and after electromagnetic theory, and then after now quantum theory. Okay, so it is being having a various developments on the theories. Okay, so first corpuscle theory is formed by the Isaac Newton. Okay, yeah, he's a Greek philosopher, and forward Greek philosophers discovered about the corpus theory, and after Isaac Newton was continuing about the he was contemplating about the theory what Greek philosophers say. So he reflected upon the reflection of light on corpus theory, how the corpus theory reflect. Okay, so how it reflect when the object is present, how the light is being reflected, and how it is being refracted. So refraction of light on corpus theory. So how it is being refracted. So all of the thing is being observed here. Okay, then after if you see that wave theory. Okay, though it is being after it being, they are saying about the wave theory. So what are the test and complementers of the theory? Okay, so corpus theory is upgraded towards the wave theory. So he is telling about the here they are telling about the ether medium, hypothetical medium called ether. So they are observing that ether medium is there, that it produces the wave theory. So if you have a crystal, if you draw a line on the paper and if you place the crystal, we can observe that two lines are being observed. So that is the observation of a double reflection. Okay, it is being reflected. So it is it's in the wave theory. Then after Eisen principle. So what is saying? Okay, so Eisen principle is geometrical constructions of fine position of the wavefront further instant. Okay, so he is telling that source is being present in the center, and the light rays are being passed toward the curved surface of the lens. Okay, so here he is telling about the Heisenberg principle. Then after in Heisenberg principle, the reflection of the plane wavefront and the plane surface. Okay, so how the reflection is being happening in the plane surface. So we observe that the light is being hit on the plane surface and it is being reflected. So it is being in the plane surface, it is being observed that BAC is equal to BAC and BDC are equal. Okay, so and after they propose the angle of incidence is equal to the angle of reflection. Okay, so then after quantum theory, after electromagnetic theory is being introduced, and the Maxwell's who is the one who introduced, and 1862 he introduced, and he is synthesized the electricity and magnetism and developing a quantum equation. Okay, he is using the electricity and magnetism towards the formation of electromagnetic theory. So after quantum theory is being proposed. Okay, so it was a quantum theory is proposed by means of Maxwell's Planck's constant. Planck's. Okay, so he's the one who proposed the quantum theory. Okay, so and after these are basic theory. Okay, so these four theories are very basic theories, and after we are going to analyze what are the things they are saying about these theories and what are the things they are interpreting on the light optics. Okay, so first of all, in the first unit we are going to cover about the geometrical optics. Okay, what is geometrical optics? Okay, so here the aberration is being studied. Okay, first of all we are going to take the first unit, and in the first unit we are going to cover about the aberration. What is aberration? Okay, so development of reality, departure of reality towards the ideal image. Okay, so if the image is being produced by the lens or the glass or the lens or the object or the mirror, so it is the image, it's called as a aberration. Okay, so this aberration is classified into two types. Okay, one is monochromatic aberration and the other one is chromatic aberration. Okay, so what is monochromatic aberration? So this is the first unit, the first line we are going to take in the syllabus. Okay, what is monochromatic aberration? Defects due to wide angle of incident and the peripheral interaction occurs even in the monochromatic light. Okay, in monochromatic light the peripheral incidence is being occurred. Okay, so see, so what is chromatic aberration? Due to the dispersion of light occurs light at least two wavelength. Okay, so they are using two wavelength. Okay, occur depression of light or called chromatic aberration that occurs due to dispersion of light or called chromatic aberration. Okay, So the further the monochromatic aberration is divided into 5 types. What are the 5 types? A spherical aberration, coma, astigmatism, curvature of life, curvature of field, distortion. Okay, well, these are the 5 major subdivisions are being occurred on the monochromatic. Okay, monochromatic aberration. Okay, so now then after that, then size derivation. Deviations from the size, shape, position of the image towards the calculation, and is called as a aberration produced by the lens. Okay, so then after, if we see the spherical aberration, what is spherical aberration? So spherical aberration is a lens made prism. Okay, so here the lens is made up of prism, a large now composition of a prism formed to be as a lens. Okay, so the increasing of angles from the center outward case of the convex lens. Okay, decrease in angle towards the convex lens is called the increase in angle if the center of the outward case is called convex lens. Okay, the decreasing angle in case of concave lens. Okay, the ray of light falls on the prism is larger angle, deviate more towards the basic of prism, smaller angle. Okay, means larger angles makes larger deviation, the smaller angles makes smaller deviation. Okay, so the peripheral light rays passes through the lens, reflect more and come to focus close to lens. Okay, so the reflection is coming when close, it is reflected. Okay, the ray pass through the different zone of lens surface comes to different focal, and the image formed by the paraxial ray will surrounds by the diffuse hollow formed the peripheral rays. Okay, so here in this diagram we can observe that the object is being kept and the lens is being kept in the middle of the thing, and we can observe that IM is differ from the IP. Okay, so there is a diffraction in the longitudinal spherical aberration and then lateral spherical aberration. So these are the circular list confusion. Okay. The spherical aberration produced by lens depends on the distance of the object point and various approximata or square of the distance of the object ray above the axis of the lens. Okay. Then after we are going to see how the spherical aberration can be reduced. Okay, the reducing of spherical aberration. Okay, so this spherical aberration produced lens is minimized or eliminated by the following methods. What are the methods they are using here? Okay, the spherical aberration. What is the thing? Okay, first of all, minimizing to stop. Okay, how to minimize? Using stop method. Okay, so the effect of lens appears. The stop used can be such as to permit either the axial ray of light or margin ray of light. However, the amount of light passed through the lens is reduced. So if the light is passed through the object, it is being reduced, and correspondingly it makes the object, the image appears to be less brighter. Okay, so this makes that the object is being less brighter. The penetration high, the object will be very bright. Okay, so if the penetration is low, the object will be very low. Okay, the brightness will be very low. The second is the longitudinal spherical aberration produced by the thin lens for the parallel incident beam. Okay, so here we can see the equation. X is equal to rho 2 by F2 K2 nu 2 nu square plus K, and the further equation we can see in the diagram as 9.3. Then after, the X is determined as longitudinal spherical aberration, and rho is the radius of the lens aperture, and F is the secondary principal focal length. Okay, so K is equal to R1 by R2. Okay, where R1 and R2 are called radius of curvature for the given value nu F2 and rho. Okay, consideration consideration for the minimum spherical aberration. Okay. So from the then after if we differentiate the equation 9.3, then we can observe that k is equal to r1 by r2, that is equal to nu 2 nu minus 1 minus 4 divided by nu 2 nu plus 1. Okay, so it's a equation. So therefore, after we are going to see the final thing, that mu is equal to 1.5 and k is equal to minus 1 by 6. Okay, so here the length is being kept, and Fm and Fp are being kept here. Okay, so here the cross length is being observed. Okay, so r1 by r2 is equal to minus 1 by 6. It's a clear of the figure that the derived produced by the two surface is same as an axial and marginal ray of light comes to focus with minimum spherical aberration. Okay. Then after, plane convex lens are being kept for the using the optical instrument so as to reduce the spherical aberration. So here they are using the plano-convex lens. Okay, so by using this plano-convex lens, we can reduce the spherical aberration. So R1 by R2 is equal to minus 1 by 6 is only 8%. Okay, less than that of a plano-convex lens. Okay, having the same focal length and the radius of the length aperture. Okay, so here they are minimizing the reflection. Okay, so here we observe that here they are using the different lenses, and how they are finding that Fm and Fp or has a variation. Okay, so therefore here Q is equal to R1 plus R2 divided by R2 minus R1. Okay, so the plano-convex lens, when the plane surface face the parallel beam of light, deviation is produced only at the curved surface. Okay, only at the curved surface the deviation beings occur. Hence that longitudinal spherical aberration. Okay, the more that when the curved surface first, the incident light, in the latter case the spherical aberration is less than the former. Okay, so in the spherical aberration it is less. Okay, so here they are having a curvature. Okay, space factors. Okay, then after, spherical aberration can also be made minimizing by use of two plano-convex lens. Okay, so first of all they are using the plano-convex lens with single use, and after they are using the two plano-convex lens in order to reduce the spherical aberration. Okay, the distance between them are reduced by using the focal length is being reduced by using two lens. Okay, so the two plano-convex lens focus on the light F1, F2 are separated by the distance d. Okay, here we can see that d is the distance F1 minus d. Okay, so the total distance between the first plano-convex lens and then after up to the F, that is focal length F1, it is called as an F1, and then after the distance between the two plano-convex lens is called as d, and the distance between the second convex lens towards the focal length is called F1 minus d. Okay, so then after, then delta angle of deviation produced by each lens is shown in the figure, that is angle B F1G is equal to delta, that is equal to delta angle F1BG is equal to delta. Okay, so they are having the both side or being delta on both sides, means the angle of BF1G is equal to the angle of BF1BG. Okay, so therefore triangle BGF1 is BG is equal to GF1 or O2G is equal to GF1 approximately. That is O2G is equal to half O2F1, that is equal to half F1 minus D. For the second lens, F1 is virtual object and G is the real image. Okay, so substituting these values on obtain an image distance is formula. Okay, so we observe that 1 by epsilon is minus 1 by u is equal to 1 by f2. Okay, therefore instead of writing v, that is 1 by O2G minus 1 by O2 F1 is equal to 1 by F2. Therefore, by simplifying this term, we can observe that 2 divided by F1 minus D minus of 1 by F1 minus D is equal to 1 by F2. Okay, therefore, the simplifying this, one side becomes 1 by F1 minus D is equal to 1 by F2. That is, after the F2 is being F1 minus D is being replaced to the upper side, and then F2 to the other side. F2 is equal to F1 minus D, or we can say that D is equal to F1 minus F2. Thus, the conditioning of the minimum spherical aberration is that of distance between the two lengths. So what they are saying? The minimum spherical aberration is that the distance between two lengths is equal to the difference in focal length. Okay, so the distance makes the focal length to be varied. Okay, so if the distance is varied, the focal length will be varied. Okay, so they are saying that the spherical aberration for the convex lens is positive, and that of concave lens is negative. Okay, so for the spherical aberration for the convex lens will be positive than that of convex lens. Okay, whereas concave lens is negative. By a suitable combination of convex and concave lens, spherical aberration can be made minimum. Okay, but if we have a slight variations between the convex lens and concave lens, we can minimize the spherical aberration, and we can minimize the spherical aberration. Okay, the spherical aberration may be minimized by using the axial GRAN lens. Okay, so by using GRAN lens, it can be minimized. Okay, so today we are going to see this section. Okay, so that's the end of the session. So here we saw about the what is the aberration, and what is the spherical aberration, and then after how we can reduce the spherical aberration in various formats and various methods. What are the types of lenses we can use in order to reduce the spherical aberration? We saw this. Okay. So thank you for this session. Thank you for listening. Thank you once for all. Thank you to you.